So for our next section in Chapter 2, we're going to be looking at bar graphs and histograms as another way to describe what the data actually looks like. So last section we worked with our frequency tables and frequency distributions, and we saw how numerically we could kind of see what our data looks like. And so now what we want to do is more or less take our frequency distribution and graph it, is the idea. So when we're thinking about what we're trying to do with statistics in general and what we're trying to figure out with our numerical summary, so this just kind of gives us an idea of where we're heading throughout this chapter 2. So some things that we're interested in knowing about is where does a data point fall in the data set? So does it fall to the left? Is it kind of in the middle? Is it to the right? So those are things that we're interested in. We want to eventually be able to figure out where is the center located, because that's going to be an important part of anything that we do in statistics. Is the data symmetric or skewed? So we'll talk more about what that means a little bit later if you don't necessarily know what those words are, so don't worry about it right yet. And how spread out or how clumped up is our data. So again, these are things that we'll talk about in a little bit. So the two ways to represent that we're going to talk about for data is going to be either a bar graph or a histogram. Now, typically in statistics, the one that we're going to use almost exclusively are histograms, but I also want to explain what a bar graph is and what the difference is so you can tell the difference just in case you encounter both of them. So bar graphs are going to be bars that are not touching each other. So there's going to be a little bit of a space in between the two bars. They don't actually link together. And one of the reasons that they don't touch is because bar graphs are typically dealing with discrete data. So we're looking at how many things are in the set 1, how many things are in the set 2, stuff like that. And so there's this automatic kind of separation between them to begin with. So they can either be drawn vertical or horizontal. They can be drawn either way. And so again, they're often used for quantitative non-numeric data because again, the categories are separated. So our histograms are kind of the opposite. So again, these are going to be made up of bars, but we want them to actually touch each other so that there's like a continuation from one into the other. So pretty much almost all the times the bars are going to be pointing up and down vertical. So again, these are going to be mostly used for numeric data. So the horizontal axis is going to be labeled with whatever the data represents, and the vertical axis is going to be the frequency or the relative frequency, depending on which one we're trying to graph. And so again, the histogram is basically a graphical version of our frequency distribution that we just did in the last section. So if we look, I've got a picture of one of each kind. So notice on the left we've got our bar graph. And so again, notice that we've got our bars are separated from each other. They're not touching or anything like that. Where on the left-hand side, or our right-hand side, our histogram, we've got our bars starting at 1, connecting to 2, 2 connects to 3, 3 connects to 4, and then 4 technically connects to 5, even though there's no number 5 written down in that case. All right, so let's first start off with some bar graphs, just so we can get an idea of what's going on. So we've got a set of data where the city's broken down into 6 districts, and the following table shows the percentage of the total registered voters that live in each district, as well as the percentage of total of the entire population. So what we've got is our registered voter population is our middle column. Our right-hand column is our overall city population. And down below, so this is our bar graph of our registered voter population at the moment. So notice we've got at 1, we've got 15.5, 2, we have 12.2, 3, we have 9.8, 4, we have 17.4, 5, we have 22.8, and then finally for 6, we had 22.3. Again, since the bar graph, none of the bars are touching or anything like that, and we try to center the bar so that the middle lives wherever that number is that we're looking at. All right, so now what we want to do is do the same thing But in this case, we want to graph what the overall city population is. So we're going to kind of do it the same way. So our District 1 is 19.4. So what we want to do is we want to go up to about almost 20. So this is about one of the ugliest bars I've ever seen, but that's okay. So our number 2 is 15.6. So again, just make sure they're not touching. Go a little bit above 15. And again, try to center these in here. Theoretically, the rectangles should be the same width, so just pretend mine are. For 3, we've got 9, so we're going to be a shade under 10. For 4, we've got 18.5. For 5, we've got 20.7. And then finally for 6, we've got 16.8. And again, if you want to, you can write above, just like we had above, what the different numbers are and things like that to represent how high that bar actually goes. So you could write the percentages there, but you don't have to. So, all right, so that's our bar graph. Now, one of the nice things that you can do with bar graphs that you can't do with histograms is you can actually put them on the same chart. So notice what we've done is we've combined both the voters compared to the total population, so you can just get an idea of how the percentage of voters compares to the total population and what percentage was there. So that's kind of a neat way to compare those two graphs. And then another thing that you can do with bar graphs is what we can do is we can actually change the bottom order. So notice our city district, instead of going from 1 to 6 now like it did before, now we're ranking it according to the highest percentage down to the lowest percentage. And so again, we can do this with the bar graph, but we do want to be mindful that we make sure that we change these bottom numbers so that they also move along with that bar as well. All right, so if you have any questions or anything about bar graphs, definitely send me a message and let me know. So the more important thing that we're interested in is being able to draw a histogram given certain pieces of information. So for example 2, we've got data related to iPads. And so we've already got our frequency table drawn. So our goal is we just want to draw what the histogram for this looks like. And so again, we are drawing a histogram. So we want to make sure everything's connected to each other. And so since we're looking at the frequency, we're not actually dealing with this column. We're just focusing on the middle frequency that we have. And so we can see that our value of 0 has a frequency of 5. So with this one, since it's a histogram, we want to start at 0, go up to where 5 is, and then go the whole way over and connect to 1. And then 1 goes up to 8. So we're going to go up to 8. Again, go the whole way over until we hit 2. 2 goes up to 14, so we're going to go way up here, and then the whole way over to 3. 3 goes to 13, so we're going to start kind of here in the middle, go over to 4, and come down. 4 is at 6, so we're going to go from here over to 5, and then finally 5 is at 4. And so we're going to drop that down. And so even though technically 6 isn't in our data set, I do need that 6 there as a way to finish off my histogram. All right, so that's what our histogram would look like. And again, if you wanted to, you could put the numbers here to represent the different heights. And so it does help sometimes to look at them, but again, not necessarily necessary or anything. All right, so I've got a bunch for you guys to work on here. So if you have any questions or anything like that, just let me know, and I'll have guys take pictures of these and share them up so we can compare answers and make sure they all look good. So if you have